Morning, calculus class today. So I want to talk about section 6.5. So this one, it's about the average value. Okay, so if you guys want to start with the warm-up problem, so here's the one. It's about the revolution around the x-axis or the y-axis, finding the volume. So a tang on the wing of a jet aircraft is formed by revolving the region bounded by the graph of y equals 1/8 x squared times square root of 2 minus x, and bounded by the x-axis, where x and y are measured in meters. Find the tank's volume. So once you get the positions, find the point where the graph and the x-axis intersect, so you can get those upper bound, lower bound value. So basically, this one you can just integrate it by using the this method. So eventually, you'll get pi over 30. Okay, so now let's take a look at this. So 6.5, average value of a function. So anytime they want to find out the average value of something, so such as what? Time, pieces, score, etc. So what happens when you have an infinite number of possibility? So for instance, finding average temperature like this. So let's say that the graph, so you want to find out the average temperature from a certain time period. Finding the average value. So let's say we are working with the interval from a to b with n equals subinterval, then each length it's divided by, so delta x, it's from b minus a divided by n. N, where's the equal subinterval? So we try to do it with x1, x2, x3, all the way to x sub n. So in consecutive interval, we can calculate the average of the numbers. So let's say that we're finding the average number. So f of x1 plus f of x2 plus f of x3, so on and so, divided by n. So let's say that we have those kind of a structure. So delta x, so that's just the average distance for the width of the rectangle. And then the other one is just the average length for the rectangle. So let's put this all together. So n can be calculated by b minus a over delta x if we just cross multiplied it. And then substitute that into n here. So this one can be calculated by 1 over b minus a times delta x times the quantity of f of x1 plus f of x2 plus blah 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 all the way to f of x sub n. So again, this one is just like algebraic manipulation. It's just the proof. So anytime that you divide it by a fraction, you multiply by the reciprocal. So this part right here. So we just flip it over, and then you just multiplied it. And now, so this one is just like a general proof for finding the average value of anything. Okay, so here's what we found. Delta x, we just want to distribute. And this one is considered like a summation with all the rectangle. So let's say that you want to sum up all the area of the rectangle. I equals 1, so all the way to n rectangle. So f of xi times delta x is just the length times the width. So once you sum up the area of all the rectangles, so this one looks kind of familiar. It's actually finding the area under the curve. So we're using that the integral. So integral from a to b, f of x delta x. So the mean value theorem for the integral, if f is continuous on closed interval ab, then there exists a number x in the interval, closed interval a and b, such that f of c, the average value of the function, equals 1 over b minus a times the integral from a to b, f of x delta x. So that's the main formula that you need to recognize. And then integral can be solved by using f of c times b minus a. Again, this one we just want to solve for f of c. Solve for the integral. So here's the first example. Find the average value of f of x equals 3x squared minus 2x on the interval from 1 to 4. So first thing that you want to find out is that 1 over b minus a. So we got 1 over 4 minus 1. It's the integral from 1 to 4, and the function is a quadratic. It's a quadratic binomial, so we put it in as the integrand. And then integrate it with respect to x. And then using FTC part 2, And then we got 16. Okay, so now, so the sound barrier. So this one can calculate that the average speed of the plane. So this one was the first time that, okay, the fighter, so that broke the sound barrier. So the average speed is 299.5 meters per second. So that's pretty fast. So at different altitude in Earth's atmosphere, sounds travel at different speeds. That's true. So this one has something to do with physics. The speed of the sounds, so S of x in meter per second, can be modeled by the linear function. So we need to find out the average speed for the sound travels. So x is the altitude in kilometer, and what is the average speed of the sound over the interval from 0 to 80. So basically this one we just want to integrate it from 0 to 11.5, but we do have different function here. So the other one is from 11.5 to 22, 22 to 32, so the third piecewise functions, and then the fourth one from 32 to 50, the altitude, and then 50 to 80, so we do have different structure here with the functions. Again, it's a different speed, okay, so that's why it's completely different. So that's why we need to break it apart into 1, 2, 3, 4, 5 integrals. And then, so basically just calculate them. Combine them all together, so you got 24,640. By the way, this one you can just do it manually, or you can just do it on the calculator. Combine them all together and then divide it by 80, because you want to find out the average speed. And here's what we got. It's about 308 meters per second. It's pretty fast. And here's another one you can try. So find the average value of the functions f of x 4 minus x squared over the interval from negative 2 to 2. So find the value of c that exists between negative 2 to 2. So finding the average value, basically using the formula 1 over b minus a times the integral from a to b f of x dx. And here's what we'll get. A third. So since you need to find out what f of c is, the value of c, so we set a third, so that equals 4 minus c squared. So that just equals the average value, and then solve for c, so we got plus minus 2 root 3 over 3, algebraically. And here's another problem that I can try. It's just one of the AP problem. So finding the average value, y equals cosine of x over the quantity of x squared plus x plus 2 on a closed interval from negative 1 to 3. So basically this one you can integrate it on the calculator, and then so just divide it by the difference of negative 1 and 3. So the answer most likely is going to be C. It is. Okay, so thank you for watching the video today. So any questions, any comments, so please let me know. Just put it on my YouTube channel. And I'll see you guys next time.